Here we are just kind of recapping this whole idea of slope and actually how to find that. Suppose that we have this point A right here and we have some other point B. Now, anytime you have 2 points, you can always find the slope between those 2 points, every single time. Now, how do you actually find this whole thing slope? Well, as we can see, we ended up rising to get from A to B, we ended up rising a certain set of y values. Likewise, we also ran a certain set of x values. In other words, this was the change in y over our change in x. How much did those x's change by? How much did those y's change by? So for slope, we again know that it's the change in y over change in x, or our rise over our run. Well, if for example we wanted this to be some arbitrary a, well then that has some point, again a is some point, where we have some x value and some y value. So for right now we'll just call them x1, y1. Likewise b has some x and y value. Just to distinguish the difference between the two, I'm just going to call this one x2 and y2. That helps us actually in determining which points we're actually talking about. Now, when we're discussing the change in y's, in other words, our rise, what we can do is actually find the difference between our y values. So as a result, we're going to take our y2, and again, if we're looking for the difference between our y values, we would subtract our y1. This is over our run. In other words, the change in our x's. So we end up with x2. And again, we're trying to find the change in that, the difference in our x's. So that's why we're going to be subtracting by our other x, x of 1. So this is actually how we find slope, y2 minus y1 over x2 minus x1. Now let's actually go ahead and apply just a quick example so we can kind of see this in action. If we look carefully, we see that point A happens to be at -1, -2. And B happens to be, it looks like it's 5, 1. Notice they are 2 different points altogether. And that's why this guy was like x1, y1, this is some x2, y2. Again, just to kind of distinguish that these are different points. Now just going ahead and pretty much throwing them into our equation to find a slope, we end up with y2, here is y2, it's 1, minus our y1, here's y1, it's -2, over our x of 2, here's x of 2, it's 5, minus our x of 1, here is our x of 1, -1. So anytime you are subtracting by a negative like this, you're actually adding these. So we really have 1 plus 2, which comes out to be 3. Likewise, we're subtracting by a negative here, so we end up actually adding that. So we end up with 5 plus 1, which is 6. So 3 divided by 6, that can be simplified down to 1/2. In other words, our slope between A and B is 1/2. We can even see that if we were to start at this point A and go up 1 over 2, there's in fact a point there. Likewise, we go up 1 over 2 more, there's another point. Up 1 over 2, in fact, finally ends up at B. So this rise over run is actually, this 1/2 is the simplified version of the change as you're rising and running. It did not matter which one was actually x1 and y1. If you think about it, if you're finding the slope between 2 points, it doesn't really matter which one is considered to be x2, y2, and which one's x1, y1, because as long as you do all the math correctly, you should end up being fine, okay? So again, it doesn't really matter which one's x1, y1, which one's x2, y2, because again, you're still finding the slope between these 2 points, and that's not ever going to change, provided all of your algebra is done correctly. Now, if we are looking at a line that is rising from left to right, we should be seeing something that does this. And as a result, that has a positive slope. Alternatively, if you're falling from left to right, you would see a graph doing something like this. And as you guys can tell, it's falling, it's going downwards, so that should have a negative slope. If you are in fact horizontal, that is more or less horizontal, then you would be having no slope. In other words, you're not up or down any. This is also known to be zero slope. If you are vertical, so if you're seeing something like this, that's actually an undefined slope. Now, when we're looking at two lines that are parallel with one another, so for example, now if we're looking at two lines that are parallel with one another, here could be one line, another line that's in fact parallel with it. Oh, that's a really bad image. Let's clean that up a little bit. There is more or less a parallel line, set of parallel lines. Then as a result, you can kind of see that they are rising and running at the same rate. So they should end up with the same slope. And if two lines are in fact perpendicular with one another, so if I just say here is one line, and then here is another line, if they are in fact perpendicular with one another, they should create a 90-degree angle. And this happens anytime, or at least if you're looking for, when you're looking at the slopes, they actually end up having opposite reciprocal slopes. So they have to meet both criteria. So opposite reciprocal. And pretty much what that means is you would just take the opposite sign, and reciprocal is pretty much where you see the flip in your fraction. So again, though, that is just kind of looking at slope a little bit more in depth and all the kind of different scenarios and where we can actually see different types of slope and really what they should be. In other words, if you see a graph that's kind of rising from right or from left to right, you should see a positive slope there. All right, you know, if two lines are parallel, they should have the exact same slope. And again, though, that is from our 2.2, 2.3 set of notes.